In March 1945, the German High Command looked at the Rhine River and saw salvation. Standard engineering manuals dictated that bridging this freezing, fast-flowing current to support heavy armor would take the advancing Allies weeks. It was the ultimate natural fortress, guaranteed to buy the shattered Wehrmacht time to regroup. But when German artillery spotters scanned the morning fog, they didn't see early construction camps. They saw fully operational steel treadway bridges already spanning the water, carrying a continuous tide of American Sherman tanks into the Reich. Germany's final defensive line hadn't been broken by a miracle. It had been systematically dismantled in a matter of hours.
The enduring narrative of the Rhine crossing often centers on a singular, dramatic stroke of luck, the capture of an intact railway bridge at Remagen. But attributing the collapse of Germany's western border to a single fortunate infantry action obscures a far more terrifying reality for the German defenders. The true conquest of the Rhine was not a spontaneous improvisation of battlefield bravery, nor was it a miraculous stroke of tactical fortune. It was a brutal, calculated application of industrial mass production, specifically engineered to overrun a massive natural barrier with machine-like precision. How did the United States military construct a continuous, highly mechanized highway across a contested, freezing river in a fraction of the time predicted by standard military doctrine? The answer lies hidden in a complex, overlapping web of predetermined logistics. This was a synchronized operation requiring specialized underwater shore reconnaissance, the stockpiling of thousands of standardized steel treadways, and the deployment of specialized bridge-building battalions operating under the umbrella of massive, overlapping anti-aircraft cordons. Every variable, from the velocity of the icy current to the exact load-bearing requirements of a Sherman tank, had been mathematically accounted for long before the first assault boat hit the water. To understand how this impossible timetable was achieved, and to comprehend the profound shock experienced by the German General Staff, we cannot simply look at the courage of the combat engineers under fire. We must first strip away the myth of the miraculous American advance and confront the cold, unyielding reality of extreme industrial calculation. And that calculation began with understanding the devastating physical reality of the river itself and the desperate strategic climate that forced the Supreme Allied Command to authorize such a massive, synchronized gamble. The tactical reality confronting Allied commanders in early 1945, as they locked eyes on the eastern bank of the Rhine, was defined by a terrifying, unrelenting constraint. They were not facing a political border. They were facing a physical, hydrological engine of destruction. The Rhine, swollen by the spring thaws of the Alps, was a monster. This was not the narrow, placid water of the Seine or the Meuse, which the American engineers had already crossed using standardized techniques. Here, the river width expanded dramatically, in some planned crossing sectors exceeding 1,000 feet of open, freezing water. The velocity of the current was the defining factor for every engineer officer studying the maps. It was moving, on average, at 5 to 7 miles per hour. That figure, recorded coldly in hydrological surveys, translated on the surface to a churning, chaotic force that would pitilessly tear at any structural component placed within it. A conventional anchored boat, even one designed for bridging, would be ripped from its moorings in minutes. Standard pre-war engineering manuals, utilized by German defenders to calculate their defensive timelines, explicitly stated that constructing a heavy-duty bridge over a river with this combination of width and velocity was a deliberate, multi-week operation requiring massive, specialized construction teams and heavy equipment working in relative safety. This environment of extreme physical pressure defined the operational setup. It was a conflict not yet fought with artillery, but with raw physics and material endurance. The American military doctrine, fundamentally built on the premise of industrial mass and overwhelming fire superiority, now found itself facing a bottleneck that could, if managed incorrectly, render that mass useless. If an assault division were to push infantry across in flimsy, plywood and canvas assault boats, an action already categorized by senior commanders as a likely suicide mission under observed enemy fire, that infantry would be instantly isolated. German doctrine was very clear. Counterattack the bridgehead, destroy the isolated infantry, and throw them back into the river before they can consolidate. To survive, to push past the immediate shoreline, that infantry required heavy armor support. They needed Sherman German tanks and tank destroyers to break fortified bunkers. And the only way to get a 30-ton Sherman tank across that specific body of water was a heavy load-bearing bridge. The real strategic dilemma, the true pressure driving the Allied High Command, was the realization that engineering speed was the only variable that could prevent a catastrophe. Any delay in establishing a bridge meant an expanding time frame where the isolated infantry remained exposed to overwhelming counterattack, potentially leading to the complete failure of the crossing and the collapse of the offensive. The clock, for the engineers, was ticking long before the first shot of the assault was fired. Their true antagonist in this setup phase was not merely the German artillery observer, but the logistical impossibility of secrecy. To meet this demand for impossible speed, the Allies had to move thousands of tons of bulky, heavy, steel treadway bridging components, countless pontoon floats, and specialized power tools to the edge of the Rhine in absolute secrecy. This movement of materiel was, by itself, a logistical nightmare of terrifying proportions. A single 200-foot pontoon bridge required a convoy of nearly 40 semi-trailers just to move its components. The noise of this movement was devastating. The logistical footprint was visible to any aerial observer. If the German High Command correctly identified the location of these massive construction stockpiles, they would know with mathematical certainty exactly where the hammer would fall. They would then zero in every available artillery piece, potentially turning the crossing site into a kill zone where construction would be impossible. Therefore, the conflict was defined by a desperate, high-stakes game of hide-and-seek. The success of the eventual assault required not only engineered speed during construction, but engineered deception before it. Massive convoys of bridging equipment, moving by night with blackout lights, navigated the destroyed infrastructure of France and Belgium, converging on specific, carefully prepared forward logistics depots. Every movement was synchronized, every detour mapped. Engineers working in advanced units prepared concealment structures, utilizing smoke generator units and camouflage netting to hide acres of heavy steel components from the prying eyes of the Luftwaffe. Adding to this atmospheric pressure was the internal friction within the Allied command itself. This was not a monolithic machine, but a complex collection of massive national armies competing for priority. There were profound, sometimes bitter strategic disagreements over whether the main effort should focus on the 21st Army Group's massive, set-piece operation to the north, or the rapid, decentralized, opportunistic advances of the 12th Army Group. Every engineer asset allocated, every convoy of steel treadway components, every amphibious truck, the vital DUKWs, assigned to one sector was materiel that was unavailable for another. There was a pervasive dread among engineer units that a logistical miscalculation, a single prioritized movement that was delayed, could create a chain reaction resulting in failure. The setup, therefore, in early 1945 was a scene of intense, suppressed chaos. It was a mobilization of material mass that defied the logic of battlefield movement. This logistical and hydrological conflict is precisely what led the German defense planners to underestimate the speed of the American engineers. They looked at the Rhine, they consulted their engineering data, and they logically concluded that the advanced material preparation necessary for a rapid crossing was impossible. They calculated that even if the Allies seized a bridgehead, the immediate, rapid construction of heavy-duty armor crossings could not be achieved before a German counteroffensive could isolate and destroy the initial wave of infantry. This calculation of defensive security, however, was based on an outdated pre-industrial definition of military engineering. The German leadership understood defensive fortifications, and they excelled in decentralized tactical leadership. But they were about to be confronted by an organization that had applied corporate management principles, production standardization, and synchronized logistics directly to battlefield construction. In the dark, hidden depots west of the river, specialized bridge-building battalions, numbering tens of thousands of men, were not just waiting. They were engaged in relentless, repetitive, synchronized drills, training with the exact standardized equipment they would soon push into the current. The conflict in this setup phase was defined by this invisible preparation. It was defined by thousands of tons of material, organized with machine-like precision, straining against the massive natural barrier of the river, waiting for the signal to begin. This entire clandestine effort was structured around a singular, high-stakes assumption that when the moment came,
These engineers could perform like a choreographed industrial machine, turning the impossible timelines into historical fact. This was the engineered solution to an existential strategic problem, a mechanical assault on a natural fortress, preparing to deploy with a fury and efficiency that would shock the defenders. The signal to unleash this mechanical assault did not come with a whistle, but with a localized earthquake. Across the designated crossing sectors, the pre-dawn darkness was instantly eradicated by the blinding flash of one of the most concentrated, meticulously planned Allied artillery barrages of the entire Western campaign. Thousands of high-explosive shells walked across the eastern bank in a rolling wall of concussive force, systematically deafening the German defenders and completely disrupting their established defensive posture. Under this terrifying umbrella of screaming steel, the initial wave of plywood assault boats hit the freezing water. The infantry within them paddled furiously, braced for the immediate slaughter that standard military doctrine promised. Standard procedure, the very doctrine the Wehrmacht relied upon to calculate their counterattack window, strictly dictated that engineers must wait. They were supposed to hold their bridging equipment on the western shore until the assault infantry had carved out and fully secured a deep, impenetrable perimeter on the far side. But the American commanders knew that waiting meant losing. The moment the first riflemen scrambled up the eastern bank, American shore reconnaissance teams deliberately shattered the established rules of engagement. Instead of holding back, these specialized engineer teams plunged directly into the freezing, waist-deep mud right on the heels of the infantry. Working exposed under the chaotic light of parachute flares and the immediate, erratic crack of small arms fire, these scouts ignored the firefights erupting just yards away. Their sole objective was geometry. They frantically surveyed the gradient of the bank and pounded heavy steel stakes deep into the riverbed to mark the critical anchor points. Before the infantry had even cleared the immediate tree line, combat engineer battalions were already hauling heavy pneumatic pontoon floats down to the water's edge, muscling the massive, unwieldy rubber and canvas shapes into the violent current, while zeroed-in German mortar fire began to throw pillars of freezing water into the air around them. It was at this precise moment, peering through the smoke and the lingering fog of the artillery barrage, that German forward observers experienced a profound, paralyzing shock. They were looking for the telltale signs of conventional bridge building: timber being cut, pilings being slowly driven into the riverbed, the methodical, vulnerable pace of traditional construction. Instead, what materialized through the optics of their periscopes defied their entire understanding of combat engineering. The American equipment was completely modular. Huge, heavy-duty trucks backed right up to the water, dropping prefabricated steel segments of the M2 treadway bridge. The engineers weren't building a crossing from scratch. They were rapidly assembling a massive industrial puzzle. The steel tracks, specifically designed to carry 30-ton Sherman tanks, were literally snapping together, locked into place by heavy steel pins driven home with sledgehammers, by men standing knee-deep in the churning water. The conflict immediately shifted from an infantry skirmish to a desperate, terrifying mathematical race. Hidden in the hills above the river, German artillery spotters frantically worked their radios, attempting to calculate firing coordinates and dial in their heavy guns on the crossing sites. Artillery requires calibration, a process of bracketing a target with test shots, observing the impact, and mathematically adjusting the trajectory. But the target below them was moving and growing with terrifying speed. Every time a German spotter called in a correction, trying to drop a high-explosive shell directly onto the bridgehead, the American engineers had already pushed the structure another 50 feet out into the current. The relentless, practiced speed of this prefabricated engineering meant the bridge was literally outrunning the arithmetic of the German artillery. The manual labor was brutal, requiring engineers to wrestle with 2,000-pound steel floats in the dark while shrapnel tore through the air. But the modular design absorbed the chaos and allowed the construction to push continuously forward. The Wehrmacht's reliance on the river as an insurmountable barrier was collapsing in real time before their eyes. Yet, locking those steel pins and snapping pontoons together in the freezing mud was only the beginning of a massive, highly synchronized industrial assembly line. The synchronization of this assembly line relied entirely on a highly specialized vehicle
that had been engineered for exactly this moment, and upon the men who had been relentlessly conditioned to operate it. As the forward engineers plunged into the freezing mud to secure the initial bridgehead, a ceaseless mechanized procession of Brockway 6-ton, 6x6 heavy bridge trucks began rolling down the cratered approach roads toward the water. These massive purpose-built machines were the absolute lifeblood of the operation. There was no hesitation in their movement, no stopping to consult tactical maps or coordinate with localized command posts. This was a choreographed industrial ballet that had been rehearsed to the point of absolute, unquestioning muscle memory. For months prior to the offensive, on the freezing waters of the River Thames in England, and later across the secured spans of the Seine and the Meuse in France, specialized bridge-building battalions had drilled these exact geometric movements until the men could execute them blindfolded. They knew down to the second how long it took for a Brockway to reverse to the precarious edge of a muddy embankment, deploy its twin heavy-duty hydraulic booms, and lower a pair of 2,000-pound steel treadways directly onto the waiting pneumatic floats. The sheer logistical scale of the M2 treadway bridge system was staggering, but its genius lay in its modular simplicity. The engineers were not building a bridge from raw materials. They were rapidly snapping together a massive, prefabricated industrial puzzle. Traffic control on the western bank was enforced with a ruthlessness that matched the combat at the front. Military police established a rigid, one-way circuit for the massive trucks. A loaded Brockway would back into position, its hydraulic winches screaming as the heavy steel sections slammed into the saddles of the rubber pontoons. The instant the steel pins were dropped into place, the truck would accelerate away, making room for the very next vehicle in the convoy, which was already idling just yards behind, its air brakes hissing in the cold morning air. There was no bottleneck. The supply of bridging material flowing from the concealed forward logistics depots was, for all practical purposes, infinite. To the engineers standing waist-deep in the churning, icy current, the war had shrunk to a series of repetitive, brutal mechanical tasks. They had to wrestle with 33-foot-long rubberized canvas floats, inflating them with heavy diesel compressors, while German mortar rounds threw columns of freezing water into the air around them. The river itself was fighting them. The Rhine's powerful current, moving at a relentless 7 miles per hour, exerted massive lateral pressure against the growing structure. To prevent the bridge from being swept away, amphibious DUKW trucks had to power their way upstream, dropping massive 500-pound steel anchors into the riverbed, trailing heavy cables back to the pontoons. The men working on the water were soaked, freezing, and operating under the constant concussive roar of incoming artillery. Yet they communicated entirely through sharp, practiced hand signals. Over the deafening noise of the machinery and the explosions, shouted orders were useless. As they locked one heavy steel section together, driving the pins home with massive sledgehammers, the next section was already descending from a crane above their heads. The bridge was not being built so much as it was being extruded from the western bank, pushing outward into the hostile current at a rate of feet per minute. The sheer momentum of this logistical train absorbed the immense friction of combat. If a rubber float was shredded by shrapnel, it was unceremoniously shoved downstream and instantly replaced by the next truck in the unbroken line. Miles away, deep inside the subterranean command bunkers of the German Army Group B, the incoming radio reports from the riverbanks were generating a localized atmosphere of intense, escalating disbelief. General Feldmarschall Walter Model and his senior staff officers were huddled over massive tactical maps, trying desperately to comprehend the geometry of the disaster that was unfolding along the Rhine. The initial reports of American infantry crossing the river in small plywood assault boats had triggered their standard pre-planned defensive protocols. Local Panzer commanders were organizing armored counterattacks, operating under the deeply ingrained doctrinal assumption that they had days, perhaps even weeks, before heavy American tanks could intervene to support the isolated infantry. The German High Command relied implicitly on the unyielding mathematics of traditional military engineering. Their manual stated clearly that the river was too wide, the current was too fast, and the bottom was too unstable for a rapid bridging operation to succeed under combat conditions. But as the morning progressed, the frantic reports coming in from their forward artillery spotters completely shattered those long-held assumptions. The spotters, peering through high-powered optics from the bluffs overlooking the river, were not reporting the slow, methodical driving of wooden pilings. They were reporting continuous ribbons of steel actively growing across the water, section by section, moving with an impossible speed. The intelligence officers in the bunkers frantically cross-referenced these reports with their engineering manuals, trying to find a precedent, any historical data point, for the velocity of the American construction. There was none. The terrifying realization that swept through the German command structure was paralyzing. The Americans were not merely securing a foothold across the Rhine, they were physically bridging it at a pace that rendered the German counterattack window entirely obsolete. The localized bridgeheads were not isolated, vulnerable pockets of infantry. They were the anchor points for massive, mechanized arteries that would soon pump entire American armored divisions directly into the defensive heart of the Reich. The tactical problem had instantly escalated, from containing a skirmish to facing an existential crisis. The standing orders shifted with absolute, desperate urgency. The infantry bridgeheads were no longer the primary target. The bridges, still under construction, had to be annihilated at all costs. The German war machine, battered, depleted, and running critically low on fuel, was ordered to hurl everything it had left at those narrow ribbons of steel spanning the Rhine. The retaliation was immediate, utilizing a combination of high-technology desperation and deeply unconventional warfare. The first wave of this desperate counterattack came from the sky. Despite the overwhelming superiority of the Allied air forces, which virtually owned the airspace over Western Europe, the Luftwaffe launched a series of frantic, highly concentrated, localized strikes. Acting on direct orders from the highest levels of the collapsing Nazi government, they deployed their most advanced surviving aviation assets. This included the Arado AR-234, the world's first operational jet-powered bomber, and the Messerschmitt Me-262 jet fighter bomber. Striking at speeds exceeding 500 miles per hour, these aircraft attempted to penetrate the American airspace, screaming down toward the river valley at low altitudes in a desperate bid to drop heavy ordnance directly onto the fragile pontoon structures. The unprecedented speed of the jets made them nearly impossible to track with standard optical anti-aircraft sights, and for brief, terrifying moments, they seemed poised to shatter the engineering effort entirely. But the German High Command knew the Luftwaffe alone could not guarantee the destruction of the bridges. The jets were too few, and the targets were too narrow. They needed precision, and they needed it at the waterline. From hidden, heavily camouflaged bases miles upstream, the Germans deployed specialized units of the Kampfgeschwader 200 and the elite marine sabotage units known as the Kampfschwimmer. These were highly trained combat swimmers, operating in some of the most brutal, unforgiving environmental conditions of the entire war. Wearing early primitive rubber exposure suits and utilizing pure oxygen rebreathing apparatuses that left no telltale bubbles on the surface, these frogmen slipped quietly into the freezing, turbulent current. Their mission was fundamentally suicidal in its design. They were instructed to use the rapid flow of the Rhine to drift silently downstream for miles, navigating the chaotic, debris-filled water in total darkness. Attached to them were heavy, neutrally buoyant explosive charges, some carrying hundreds of pounds of high-grade hexagen explosives, and specialized floating mines deliberately disguised to look like ordinary river debris or uprooted trees. The plan was terrifyingly simple. Drift invisibly into the pontoon supports, attach the massive explosives to the heavy pneumatic floats or the steel cables anchoring the bridge, set the delayed fuses, and let the river swallow the evidence. It was an invisible, underwater assault designed to rip the structural heart out of the American assembly line before it could be completed. Yet the American commanders had anticipated precisely this desperate escalation. The vast industrial planning that had brought the bridges to the river had also brought an impenetrable, overlapping shield of defensive violence to protect them. Long before the first Brockway truck had backed its heavy load into the water, massive anti-aircraft artillery, or AAA battalions, had established deeply entrenched positions on the western heights overlooking the crossing sites. The moment the Luftwaffe jets screamed into the river valley, they flew into the densest concentration of anti-aircraft fire the world had ever seen. The defensive network was entirely layered. Radar-directed 90mm heavy guns, utilizing the highly classified SCR-584 radar systems and devastating proximity fuses, tracked the high-altitude approaches even through heavy cloud cover, shredding the airspace with high-explosive flak. The lower altitudes were completely filled by thousands of 40mm Bofors guns firing at 120 rounds per minute.
And the M45 quad mounts, the devastating 4-barreled .50 caliber machine gun systems known to the troops as the meat choppers. The airspace immediately above the river was transformed into a solid, impenetrable wall of tracer fire and continuous explosions.
Furthermore, the engineers had raised hundreds of barrage balloons, trailing heavy, lethal steel cables high into the sky to physically shear the wings off any dive bomber attempting a low-level pass. The Luftwaffe attacks, despite their technological sophistication and the desperate bravery of their pilots, were systematically shredded by the sheer, overwhelming volume of defensive lead pumped into the sky. To counter the invisible, silent threat lurking beneath the surface, the American countermeasures were equally ruthless, mechanized, and terrifyingly efficient. The military did not attempt to spot the Kampfschwimmer in the churning, muddy water. They operated under the absolute assumption that the saboteurs were already there, drifting toward the steel. Miles upstream from the active construction sites, combat engineers and specialized infantry units stretched heavy log booms and massive steel anti-submarine nets completely across the width of the river channel. These created deep physical barriers that would snag floating mines, catch disguised debris, and entangle submerged swimmers in the freezing dark. Navy personnel operating small, maneuverable LCVP landing craft continuously patrolled the waters immediately above the bridges, their engines roaring as they cut back and forth across the current. But the most devastating tactic deployed against the German frogmen was invisible to the naked eye. At precise, predetermined intervals, often every 3 to 5 minutes, day and night without cessation, American river patrols deliberately rolled heavy depth charges and clusters of high-explosive concussion grenades off the sterns of their boats, dropping them directly into the freezing current. They were not aiming at specific targets. When these explosives detonated deep beneath the surface, the dense water acted as an incredibly efficient conductor of concussive force. A combat swimmer did not need to be anywhere near the actual explosion to be neutralized. The massive shockwave traveling through the water would violently crush the internal organs, instantly rupture the eardrums, and kill or incapacitate anyone submerged within the massive blast radius. The engineers had effectively turned the river itself into a weapon, establishing an acoustic kill zone upstream of the bridges. Floating mines disguised as logs were intercepted by the physical nets or detonated by concentrated rifle fire from the shore guards. The elite German combat swimmers, heavily armed and deeply dedicated, were systematically crushed by the relentless, rhythmic detonation of depth charges, long before they could even lay eyes on the steel treadways they were sent to destroy. The underwater sabotage campaign dissolved in a brutal, invisible barrage of concussive force, as the desperate German sabotage attempts shattered against the impenetrable American defensive cordon. The relentless momentum of the assembly line on the river finally reached its climax. Despite the freezing water, the constant harassment of artillery fire, and the sheer, brutal physical exhaustion of wrestling thousands of tons of steel and rubber in the mud, the gap closed. The heavy Brockway trucks delivered the final treadway segments to the eastern edge. The engineers, working with the practiced, unyielding speed of an automotive factory line, drove the final heavy steel pins into place, locking the floating sections securely to the solid abutments rapidly constructed on the far bank. The bridge was whole. It was no longer a theoretical engineering project meticulously planned on a map. It was a physical, undeniable reality spanning the impossible barrier of the Rhine. Within minutes of the final pin being driven home, the nature of the war in the West fundamentally shifted. Military police stepped out onto the heavy steel tracks, their hand signals immediately changing from construction coordination to strict traffic control. From the sprawling camouflage nets hidden on the western bank, the deep, guttural roar of massive engines echoed across the water. The first 30-ton Sherman tank slowly rolled out onto the steel treadways. The heavy bridge flexed and groaned loudly under the immense, concentrated weight, the thick rubber pontoons sinking deeply into the freezing current as the water rushed violently past them. But the structure held. The tank ground its way across the river, its tracks clanking rhythmically against the steel, and rolled off onto the eastern bank, its massive 75mm gun immediately traversing to scan the tree line. It was not alone. Behind it, precisely spaced at strict 50-yard intervals to carefully distribute the immense weight across the floating pontoons, came an unbroken, seemingly infinite column of armor, half-tracks, heavy self-propelled artillery, and supply trucks. The speed limit was strictly enforced at 5 miles per hour to prevent dangerous harmonic vibrations, creating a steady, unstoppable mechanized march across the water. This was the moment of absolute, undeniable defeat for the German command. The reports flooding in from the river were no longer about construction or sabotage. They were about a flood. The localized, fragile infantry bridgeheads they had planned to isolate, surround, and destroy had vanished. They had been replaced by an unstoppable mechanized artery, pumping American combat power directly into their unprotected rear areas. The careful mathematical calculations of the Wehrmacht, based on the deeply held assumption of a multi-week engineering delay, had been rendered completely meaningless by the sheer industrial velocity of the American bridge battalions. The Rhine, the historic, impassable natural fortress of Germany, had been conquered not by a single act of spontaneous battlefield heroism, but by a relentless, synchronized machine that operated with a ruthless efficiency the defenders could neither comprehend nor stop. However, this flawless mechanical execution masked a terrifying vulnerability that threatened to collapse the entire operation. The rapid bridging of the Rhine was not built on a comfortable margin of safety. It was a desperate, highly leveraged gamble bought with a dangerous depletion of standardized resources and a grueling, unsustainable toll on the combat engineers themselves. The sheer speed of construction was an illusion of stability, concealing the fact that the entire system was operating on a knife's edge. If the tightly choreographed traffic control had failed, or if the supply of replacement pontoon floats had been delayed by even a few hours due to a single wrecked truck on a cratered approach road, the massive concentration of waiting vehicles on the western bank would have instantly become a static kill zone for the remaining German heavy guns. The engineers were not just building a bridge, they were desperately racing against the structural limitations of their own logistics tail, praying it would not snap under its own immense weight. The tension on the western shore was suffocating. Military police officers, acting with the authority of combat commanders, ruthlessly enforced the one-way circuit. Every idling Brockway truck, every waiting Sherman tank was a critical point of failure. A mechanical breakdown on the approach roads was not a minor inconvenience. It was an existential threat to the entire crossing timeline that had to be brutally cleared, often by simply bulldozing the crippled vehicle into a ditch. The ultimate test of this vast, fragile engineering gamble, however, did not come from the German artillery or the freezing current. It arrived with the deafening roar of the first heavy armored columns. What the American command knew, and what they desperately kept hidden from the infantry crossing the swaying structure, was that the continuous, rhythmic pounding of 30-ton tanks rolling across the steel treadways was actively fatiguing the metal pins and tearing at the rubber pontoons at a rate that far exceeded standard operational limits. The physical limits of that steel ribbon were tested the moment the full armored weight bore down upon it. As long columns of 30-ton Sherman tanks, M3 half-tracks, and heavy tank destroyers pushed out past the shoreline simultaneously, the bridge reacted not like a solid roadway, but like a living, thrashing cable. The continuous weight of tens of thousands of tons of rolling metal forced the pneumatic pontoons deep into the freezing current, creating a violent, undulating wave action that propagated from section to section. The river's 6-knot current, pressing against the submerged canvas floats, twisted the modular structure sideways, threatening to shear the connecting steel pins instantly. For the combat engineers stationed directly on the swaying treadways, the situation rapidly turned into a terrifying, high-stakes battle against structural disintegration. They could not retreat to the riverbanks while the armor crossed. Dozens of men had to remain standing inches from the massive crushing tank treads as 30 tons of steel vibrated violently past their boots. The deafening, overlapping roar of anti-aircraft batteries firing at low-flying Luftwaffe bombers and the concussive thud of distant artillery were completely drowned out by the agonizing metallic screech of steel grinding against steel. The structural integrity of the entire bridge depended entirely on the immediate manual intervention of these exhausted soldiers. Working with heavy sledgehammers and massive steel drift pins, engineers fought the immense lateral forces of the river in real time. As the heavy tracks clanked over the joints, The violent flexing of the treadways continually loosened the critical connecting pins. Standing in ice-cold, spray-swept water on the edges of the pontoon saddles, men had to swing sledgehammers with brutal precision, repeatedly driving the pins back into place before the structural dynamic load tore the modular sections apart. A single missed strike or a severed pin meant an entire treadway section could buckle, dropping a 30-ton tank into the river and severing the supply line for hours. The physical strain on the men was catastrophic, working without sleep for over 36 continuous hours, drenched in freezing water, and operating under the constant concussive pressure of nearby explosions. Engineers suffered severe hypothermia, crushed fingers, and extreme physical exhaustion, yet they could not step back. When a pneumatic float was punctured by shrapnel or compressed beyond its load limit by the continuous procession of armor, engineers used hand-operated air pumps and temporary rubber patches. While the tanks were actively rolling directly above their heads, they used their own physical strength to pull, lever, and hold the swaying steel alignment while the river pushed ruthlessly against them. The bridge did not hold because of static engineering margins or indestructible design. It held because of an uninterrupted human chain of physical endurance that manually absorbed every shockwave, every structural shift, and every violent surge of the Rhine. To the tank commanders peering out from their open cupolas, the crossing was a harrowing 5-minute drive across a bouncing ribbon of metal. To the engineers standing below them in the freezing current, it was a minute-by-minute battle against mechanical collapse, fought with cold iron, sledgehammers, and sheer physical willpower. When the last Sherman of the leading armored division slammed its tracks onto the muddy slope of the eastern bank, the structural gamble paid off. The floating steel bridge had survived its maximum load test. Across this fragile, heavily flexing corridor, thousands of vehicles, tens of thousands of infantrymen, and endless columns of high-explosive ammunition were now pouring onto German soil without interruption. The natural moat of the Third Reich had not merely been bypassed by tactical luck, it had been physically conquered, crushed under the absolute weight of American industrial mass and the raw, physical endurance of the men who held the steel together. The successful passage of that first armored division did not just secure a tactical bridgehead, it fundamentally shattered the entire strategic timetable of the German defense. The Wehrmacht had staked the survival of the Reich on the physical barrier of the Rhine, calculating that even if a crossing was attempted, the complex engineering required would afford them weeks to mobilize their remaining panzer reserves and orchestrate a crushing, coordinated counteroffensive. Instead, they were completely paralyzed by a velocity they could not mathematically comprehend. Within hours, not weeks, the isolated pockets of American infantry they had planned to annihilate were replaced by fully mechanized, heavily armed divisions actively expanding the front line deep into the German interior. The final remnants of their defensive line collapsed, not from a lack of bravery, but from a total inability to process the scale and speed of the assault. The pontoon crossings of March 1945 proved that the fundamental nature of modern warfare had irreversibly shifted. Victory no longer belonged exclusively to the side with superior martial tradition or deeply entrenched defensive fortifications. It belonged to the military apparatus whose logistical preparation, standardized technology, and rigorous assembly line training could completely outpace the enemy's ability to react. The American combat engineer battalions did not merely construct a bridge across a fast-flowing river. They delivered a masterclass in how overwhelming industrial capacity, when applied with brutal, synchronized precision at the tactical level, completely dictates the tempo and the ultimate outcome of a conflict. This was the triumph of the factory floor applied directly to the battlefield. The American military had effectively weaponized mass production, transforming standardized steel treadways, interchangeable pneumatic floats, and the relentless repetition of manual labor into an unstoppable strategic asset. In stark contrast, the German defensive plan was exposed as a victim of its own ideological arrogance. The High Command had relied on outdated, pre-industrial metrics of military engineering, assuming that their own limitations dictated the absolute limits of human capability under fire. They failed to recognize that their adversary was fighting an entirely different kind of war. When those German artillery spotters first looked out over the freezing, fog-shrouded waters of the Rhine, they consulted their doctrine and saw an impenetrable natural fortress guaranteed to buy them salvation. They believed the river itself was their greatest ally. What they failed to understand
was that the river was no longer a geographic barrier. It was merely another logistical variable that had already been mathematically solved in a planning room thousands of miles away and physically dismantled by a mechanized army built to override nature itself.
The German General Staff had spent years studying the hydrology of the Rhine, poring over contour maps and anchoring their entire Western defensive survival on its freezing, turbulent currents. They had constructed reinforced bunkers, pre-registered their heavy artillery, and trusted the immutable laws of nature to halt the Allied advance. They were fully prepared to fight a traditional war of attrition from behind what military doctrine promised was an impassable geographic shield, assuming the enemy would be forced to conquer the river using traditional materials and predictable timelines. The Wehrmacht had planned to use the Rhine as their ultimate impenetrable fortress, but they were ultimately defeated by a completely different kind of adversary, an industrial juggernaut that literally brought its own bridges with them across the ocean, prefabricated, mathematically perfected, and carefully packed in the backs of 1,000 heavy trucks.